Welcome to Ask and Learn.
Okay, to start this question off, we have our equation here. Let me get my pointer. We have our equation here, and then we have the givens here. So we know Kc is equal to 9.1 times 10 to the negative 6 at 298, and we want to find the delta G standard. So we're going to use this equation right here, and we can just plug all of our knowns in. So we have Kc, that'll plug in right here. And then we have R is a constant. It's 8.314, which you see right here. And then we have 298 Kelvin, and then our Kc. So that's just a plug and chug through. If you want to pause the video and do that calculations, the answer to that comes out to be 28757 joules. Sorry, that's a little messy. 7, and this is an 8. Okay, so B asks us which way this reaction is going to go, and we can just think about the delta G. So we know that a negative delta G means that the reaction is spontaneous. So we know that if we have, say we have our product, or we have our reactants here and our products here, we know a spontaneous reaction is going to proceed forward because it requires no additional energy. So it'll happen on its own and reactions will form products. However, we have a positive delta G, which means it's non-spontaneous. I'm just going to put non-S, which means that if we have our reactions here, or our reactants here and our products here, it's going to proceed to the left. So based on our delta G value, we can say that the reaction at this temperature with the standard state concentrations will proceed to the left. Let me just write that here, left. Great. All right, moving on to part C. So we want to find our delta G, and this is different from our delta G standard of the reaction. So this is going to be at specific concentrations that we're given. So in the question, we're given certain concentrations, and we want to plug those in to find Q, since this is what we don't have in our equation. So we know this, we just calculated this. R, again, is a constant. T is temperature. So if we're able to find Q, we can plug this back in and get our delta G. So I wrote out our equation to find Q. Q is the reaction quotient. So you're going to take products over reactants and then use the coefficients. So here are the coefficients, and use those as the power. Put those to the power of each of the products and then reactants. These are all 2s. They're a little messy. Perfect. And then we need to find we were given the concentrations for each of these. So we're going to plug those in right here. I set up a little skeleton. So we're told that Fe2 plus is 0.010, Hg2 plus is 0.025, Fe3 plus is 0.20, and Hg2 2 plus is 0.010 again. All right, so we're going to solve out for that. If you want to pause the video and do that quick calculation, you should get about 1.56 times 10 to the negative 4th. Okay, so now that we have our Q, our reaction quotient, we can use this number and plug it into this equation in order to get our final answer for delta G. So I have, again, the skeleton. So this was the delta G standard that we calculated at the very beginning. Here we have our R. This is the temperature. And then we're going to take the natural log of the reaction quotient, which was 1.56 times 10 to the negative 4, and plug it in right there. Remember that you're taking the natural log of this number and then multiplying it by R and T. All right, so if you want to pause the video and do that quick calculation, you should get 739 joules. Or if you need to put it in kilojoules, you're just going to divide that by 1,000 to get 7.039.